Good morning, everyone. This is Mr. Veron, and this is our solution to Thursday's problem of the day from March 26th. So remember the original problem as John has a rectangular prism with the dimensions shown below. So it has a height of 2 feet, a width of 3 feet, and a length of 6 feet. Part A, what is the surface area in square feet of John's rectangular prism? Show or explain how you got your answer. Part B, what is the volume in cubic feet of John's rectangular prism? Show or explain how you get your answer. And last part, Maria has a rectangular prism that has different dimensions than John's rectangular prism. Her prism has the same volume as John's prism. What could be the dimensions in feet of Maria's rectangular prism? Show or explain how you get your answer. So here I have some possible solutions. So if we look here for part A and part B, we're dealing with the surface area and the volume of the rectangular prism. So the first thing I did was I drew out the prism so you could see what I was talking about. So I had said on Thursday that the surface area is really the flat parts or panels, okay, of this three-dimensional shape. So this is a rectangular prism, and it's actually made up of rectangles and two rectangles on the sides, and then four rectangles that go around it. Those are actually what we call faces. We don't call them sides on a three-dimensional shape. So we have really 6 faces to this shape. So really when I'm doing the area, I've got to find the area of each of those faces. So if we look here, we started off by finding the area of this first front face. So to find the area, we're going to multiply the length times the width. So in this case, we're going to multiply 2 times 3, and that gets us our 6 square feet. Now, if you notice down here, I also have 6 times 2 equals 12 square feet. Now, why did I do that? Because I noticed that there is a face here, and there's also going to be a face on the back side of the box that we can't actually see. Again, this box is going to have 6 faces or 6 panels. So the total square feet for those 2 faces, the front and the back, are going to be 12 square feet. Now, I also have to find the area, okay, of the other faces, which in this case are all of these rectangles. So you can see here, we have the right side, we have the top, and then of course we have the left that you cannot see, and the bottom that you cannot see. But what we do know is that the height of this is 2 feet, and the length is 6 feet. So if I multiply the 2 times 6, that's going to get me 12 square feet. And then I have 4 faces, okay, or sides, okay, of this figure. So I'm actually going to do 12 times 4 equals the 48 square feet. So that gives me the area of the other 4 faces. Now in order to find the total area, I'm going to have to add the 48 plus the 12 that I got from the front and the back. And that gives me 60 square feet of surface area for this rectangular prism. Now, in order to find the volume, our volume formula is that we take the length times width times height. So in this case, I have 3 times 6 times 2. Now, the order really doesn't matter when we multiply these together because we're multiplying the same digits. So I can change any order I want to make it easier to multiply. So I could do 3 times 6 is 18, and then 18 times 2, which gets me my 36. Or I can think in my head 3 times 2 is 6, 6 times 6 is 36. So that might be a little bit easier for some of you to comprehend. Now again, this is cubic feet. So what is the difference between square feet and cubic feet? So let's talk about that real quick. So square feet is really when we're working with 2-dimensional shapes. So in this case, I'm only multiplying 2 dimensions in the figure. I'm multiplying the length times the width. So if I look here, I'm really multiplying feet times feet, which is really square feet. Or we actually like to write it in 5th grade as feet to the 2nd power. So we can also write it like that, feet to the 2nd power. And again, that's just saying that I'm multiplying feet times feet. Now what happens when I'm doing volume is I'm actually multiplying 3 dimensions. So a length, a width, and a height. So really if I go back to my figure, I'm doing feet times feet times feet, which another way of writing cubic feet would be feet to the 3rd power. So again, that's another way of writing it because really we're multiplying not only the numbers, we're actually multiplying the dimensions, which in this case here are feet. Now, when we get to the last problem, okay, we talked about Maria had a rectangular prism with the same amount of cubic feet, okay, as John's. But what they want to know is what other possible dimensions could her box be? So if you look here, I've done it a bunch of different ways. You're going to see check marks there. I'm going to explain that in a moment. But basically how I would do this in class is give a bunch of people unit cubes and you could build it and figure out the different dimensions. But in this case, since we don't have unifix cubes, we're going to have to use number sense to figure this out. So if you look here, I'm going to explain how I was thinking. So I first started off where one of my dimensions was 1. And again, the order doesn't matter. Okay, it's more about the numbers that you're using, because again, we can multiply them in different ways. So if I know that one of my sides or lengths, okay, is 1 unit, or in this case 1 foot, I need the other 2 units when I multiply them together to equal 36. So my first option is evidently making it 1 times 36, which gets me my 36. So when I do 1 times 1 is 1, 1 times 36 is my 36 cubic feet. So that's one possible dimension of her rectangular prism. Now another way I could look at it, again, if I start off with one of those units or lengths being 1, and I make the next one 2, what would I multiply 2 by to get to 36? So in this case, I'm going to multiply 2 times 18. So that would be another possible way to get the 36 cubic units. Now again, if I have that side length of 1, if I make the other length 3, what times 3 is going to equal 36? Well, 12. So my dimensions would be 1 by 3 by 12. So again, I'm looking for the dimensions here, in this case, for these two to multiply to 36. So now again, if I have the side length of 1, okay, and I make my other one 4, again, 4 times what is going to equal 36? 4 times 9. Now you look here, I skipped over 5. Now why? Because there's nothing times 5 that's going to equal 36. So really I'm looking for factors of 36. Okay, so that brings us to our last one, which our dimensions could be 1 again, and then it would be 6, and then what times 6 equals 36? 6. So again, our dimensions are going to be 1 by 6 by 6. Now, I go to my next unit. Now, in this case, I'm starting off with it being 2. Now, my first one, again, 2 times what is going to equal 36? I need these two factors to always equal 18. So that's why I did 2 times 1 times 18 to start off. Now I put a little check mark there because we've already done 2 times 1 times 18. Now it's in a different order, but it's still the same units. So we don't want to reuse that again. So that's a check mark saying that we've already done that one. Now my next way would be 2 as my starting point. Now again, what two factors would equal 18? 2 times 9. Now 2 times 2 times 9 equals out 36 cubic feet. So that's actually a new one that we have not found yet. So that's why I circled it. Now we get to our next one, which is 2 times 3 times 6, because again, 3 times 6 equals 18. Now this has a check mark on it because this is actually the dimensions of John's box. So we've actually already used that one. So that's not a new one for her. Now I go to my next digit. So I go to 3. Now again, if I start off with 3, I'm really trying to figure out what times 3 is going to equal my 36. So it's 3 times 12. So I need these two factors again to always equal 12. So my first one would be 3 times 1 times 12, which is one I already did up here. So that's why I put a little check mark because we've already used it. My next one would be 3 times 2 times 6. And again, I put a little check mark because that's actually the same as John's, just in a different order. Which comes to our next one. I start off with 3, and again I'm going to do 3 times 4. Now this ends up being a new one that we haven't used before, so I circled that. Now what you're going to find here is all the other ones that I've figured out all end up being repeats. So if we look here, I start off with 4, so again, 4 times what is going to equal 36? 4 times 9. So I need, again, these factors to always equal 9. So 4 times 1 times 9, which I actually already used up here. So you can see that's why it has a check mark. And then I have 4 times 3 times 3, which is actually the one that we had just found in the previous example. So again, that's a repeat. And I just keep going with all the different factors that are going to make up 36. So again, if I start off with 6, what times 6 is going to equal 36? 6. So these are going to be my factors that equal 6. So again, 6 times 1 times 6, which again was already up here that we've already used. And I have 6 times 2 times 3, which actually gets us back to what John already had. So we already used those. My next one that I did was 9, okay, because 7 does not end up working as a factor of 36. Nothing times 7 equals 36. Nothing times 8 equals 36, so we go to 9. 9 times 4 equals 36, so again, I need all of these to equal 4 when I multiply them together. So 9 times 1 times 4, which is one we've already used way back up here with my 1s. And I also have 9 times 2 times 2, which is one I already used up here when I did my 2s. So again, that's a repeat. Then I went on to the next factor was 12. So 12 times what equals 36? 12 times 3. 3 is actually a prime number, so we only have 1 and 3 as factors. And again, this is one that we already did way back up here. So again, that's a repeat, so we don't need to use that one. Our next factor that we can start off with after 12 is 18. So 18 times 2, okay, is going to equal our 36. And again, these are the only two factors of 2 because 2 is prime. So 18 times 1 times 2 was one that we already used back at the beginning. So again, that was a repeat. And then we come to our last one, okay, which is 36. So 36 times what equals 36? 36 times 1. So the only factors for that are 1 times 1. Again, this is one of the ones that we did at the very beginning. So if we're actually looking at this, there are really only 1, 2, 3, 4, 5, 6, 7 different possible dimensions that you could have chosen for Maria's rectangle. You could have had a 1 by 1 by 36, a 1 by 2 by 18, a 1 by 3 by 12, a 1 by 4 by 9, a 1 by 6 by 6, a 2 by 2 by 9, and a 3 by 3 by 4. And again, you can switch the order of these, but the digits will still be the same. So basically it'd be like taking your box and flipping it over in different directions. So hopefully that solves a problem for you. Later on, I'll be posting today's problem of the day, and I hope you're able to try to solve it over the weekend, and I hope you guys had a great weekend, and we'll post our other video shortly. Thank you. Bye.